of asset property, cap theorem, all those things. And we are going to talk about all these topics, not like a database administrator. We are going to talk like a architect. Okay, because traditionally a lot of content is available on the internet which can talk about like what is architecture, how, what is that, memory components, all those things that pretty everywhere that is available. But we are going to understand the core concept. Okay, because if you understand the core concept, you can understand or make any database infrastructure, or you can create any fleet of database infrastructure. Fleet, when I say multiple nodes, multiple applications, all those things. Okay, so first of all, before we talk about the architecture, the database level architecture or anything, let's do some small a round of understanding what is what. When I say what is what, it means what we call these kind like small concepts, and later we will connect all the concepts and we will make a full architecture. Okay, so the first of all, the first thing that everyone should understand is that the first word that we should understand is cluster. Okay, so what do we understand, or what the first picture that come into your mind when I say cluster? What do you mean by cluster? The common
Combination
meaning.
of
Mhm.
Group
combination
of
of
database servers.
group of databases, combination of multiple nodes which are
Okay,
in sync with each other.
okay. In other words, you can say uh, group of group of DB server, which is logically representing it to the database, any database, right? Same thing happens with Oracle Real Application Cluster also. Okay, but but let's wear the hat of Postgre database administrator and understand that here when I refer to a cluster, they refer a cluster or a node having multiple databases. They are not talking about, they are not at all talking about multiple nodes for databases. They are not referring to this particular architecture or structure. They are referring this kind of architecture where I have a single node and multiple databases are running. Okay, so first correction in our concept, which is related to only related to Postgre. People are coming from a different technology. I just want you to just do a small addition in their concept that when I say cluster in Postgre, I mean single database instance with multiple databases running inside. People from Oracle, people from MongoDB, and people from Elastic might get confused because in their domain or in their world, in Oracle, single database means single instance. When I say instance is nothing but a database setup, including the physical and logical layer of the database. Okay. In Oracle, it's not like that you created one single instance and you can create multiple databases. No. In Oracle, it's like single database, single instance. But in Postgre, single instance, multiple databases. So this is the first correction that we have to do in our mind to understand the architecture better. Is this clear at least?
Uh, Abhishek, so
Mhm.
you said single database, sorry, single instance, multiple databases. I
Correct.
didn't understood this.
Okay, so you can say you have installed Postgre once
Hmm.
and just you are writing create database ABC, then you will create ABC in the same cluster. Then you create test one, like that your multiple databases are
Okay.
getting created in the same cluster. Multiple
got it.
databases are getting created. But if you are a Oracle DBA, if you are a MongoDB, if you are a Elastic DBA, then in your case, single instance is only belongs to single database. Mean to say, Oracle SID belongs to only one database, and that Oracle SID have its own instance. How many of you are Oracle DBA or from the Oracle side? Because for you, this concept is little different. Okay. So this is the first thing that you have to do a small change in your concept. Okay. Otherwise, when I will refer these kind of things again and again, you might get confused. Second and important thing, schema. Okay. People who are from the Oracle side, people are from the different databases. Like in Postgre, we have two kind of schemas, public schema and private schema. Okay. And what is schema? First of all, what do you understand by schema? What do we understand by schema?
Collection of objects.
Collection of named object, basically. Let's suppose I am creating a database for sales, and I want to categorize that specific tables which comes under sales. What I do, I create a schema, right? And all my sales related table goes inside my sales schema, right?
Shell schema.
Right. So in Postgre, we have public schema, which is available for publicly everyone, and private schema, or the schema which we are going to create. Okay. But in Postgre, schema and users are two different things. But if you are coming from the Oracle background, in Oracle, schema and user is same thing. So this thing you have to correct in your mind, little bit comparison I'm giving. Otherwise, what will happen when I am talking about all these concepts, you will might get confused. That's why in a very beginning stage itself, I'm telling you all these differences. In MySQL, people generally refer database to a schema. Okay. So when we create a database, sometimes people refer it as a schema. So don't get confused. People who are coming from MySQL background, their schema is nothing but database. In Oracle, schema is a schema and user are same kind of entity. But in Postgre, it's not like that. In Postgre, we have our cluster. Cluster have databases, and we have a different entity called user. Under the database, we have schema, private schema, and public schema. User is completely different entity comparing with the database. So user will able to connect to schema and he can run the queries like this. So this is the setup that we follow in the Postgre. But people who are coming from Oracle background, in their case, there will be an instance. Under the instance, there will be a database. Under the database, there will be a schema, and this schema itself will behave like a user. Okay, so this is the difference. In MySQL also similar kind of thing. We have a user. We create the user under the database. There we don't have concept of schema. There we have a concept of database, and we are connecting to the database using users. Okay. And they consider all these databases as a schema. They don't have specific schema inside. So why I'm giving this comparison? Because I'm going to use these words again and again. So when I'm using these words, you should not get confused that what I'm talking about. Okay. If I'm telling you namespace, whenever I say name space, which is also is schema. Okay. Namespace in the Postgre is also called as a schema. Make sense, everyone? Is this good? Because I am going to give you some more references, and I want you to understand the basics of Postgre first, and then we can start our class for talking about all those things. Is this clear? At least schema, namespace, all those things.
Yes. Yes.
Okay. Second thing, uh, people who are coming from the data Oracle point of view, the people who are Oracle DBA, they might have the concept of CDB, PDB, schema, all those things, but don't mix with Postgre. Postgre have simple logical representation of database, that is only database. When I say database, it means only database. I am not at all talking about PDB, CDB, that kind of concepts are not at all exist in Postgre. So don't refer that all those things. Simply refer that I'm talking about a logical part of my database. This is my database and it has table and objects. Okay, I'll talk about objects also. What is objects and all those things. But don't get confused. PDB, CDB, it's completely Oracle concept. Here we have simple database. No other layers, no other logical differentiation. Make sense?
Abhishek,
Mhm.
Jason here.
Yeah.
Good morning. So,
Good morning.
yeah, good morning. So, my question here is what we call in DB2 is it's a collection of
Mm,
objects like tables, views,
mm,
sequences, indexes,
mhm.
and all these things. Is that the same in Postgres as well?
Correct. They are the same in the Postgre and we will call it as a objects.
Yeah.
And objects are nothing but table, indexes, procedure, function, metallized view, all kind of logical object that you can think of, which can hold the data or which can work as a database object or segment like that.
So,
So you are
this
correct. Mhm.
yeah, PG underscore catalog is also a schema, right?
PG underscore catalog is also a schema. We will come into that also. Okay. So PG underscore catalog is also a schema. And
Information
when we
underscore schema, that is also a
information, correct. So in MySQL, we have information schema, right? So that is nothing but you can consider it. It is a catalog table of Postgre for comparison. For people who are from the Oracle background, they can think like V dollar databases and DB underscore views are nothing but they are also like behaves like catalog. So we'll connect all those things step by step. Okay, is it clear? I have answered your question.
yes, Abhishek. Thank you.
Yeah. So another important thing, whenever I'm telling tuple or row, it means, sorry, whenever I say tuple, it is nothing but row. Okay. So in Postgre, tuple is nothing but rows. It can be any kind of row. It can be physical row, it can be logical row. When I say physical row, it can be the row under the table. Technically, it's not physical, but it is existing. When I say rows or tuple, it can also exist in the blocks or pages. So we'll talk about that also slowly. It's clear. The people who are coming from MySQL Oracle background, in their world, under the table, we create column and rows. Okay. So when we will refer the same row, this particular row of a table, we will call it tuple in Postgres world. So don't get confused. I'm just talking about the row. Okay. And people who are coming from the Mongo's background, they can simply think like I'm talking about collections. Simple collections. Okay. Is this clear?
Yes, Abhishek.
Okay. So index is again same. Index, we call it index. So there is no differentiation, nothing. Okay. So these are the some small basics of Postgre before we start all these things step by step. Okay. Is this clear, everyone? Whatever I have just referred before starting the actual Postgre.
Yes.
Okay, so one more difference that we should understand. People are from a different database background. They call the smallest unit to store the database is block, right? We call it block, right? And in Oracle, in Postgres world, we will call it page. Okay, we'll call it pages. Okay, so what is the default page size in Oracle? Anyone? Anyone knows?
DB2 it is. In
In
DB2 it
DB2,
is 4K.
what is that?
4K.
DB2?
4K.
4K. So in Oracle,
8K.
the smallest 8K. Same concept goes to Postgre also. Here also the smallest or default is 8K. Make sense, everyone? And the people who are coming from Mongo and MySQL, if you're using MySQL, because I teach MySQL also, Mongo also. So in MySQL, if you are using InnoDB database engine, then your default is 16 KB. MongoDB minimum is 4 MB. Okay, like that. So mean to say, if you see from the architecture point of view, here and there, or some, if you just ignore the some kind of logical calling or logical wordings or technical jargons, end of the story, your technical architecture is remain same. The only thing is you have to change your goggles, or you have to change your angle of seeing every database. But if you understand a single database or operating system concept, you can understand any database. Okay, even it is Redis, even it is Yugabyte, even it is any modern databases like TIDB or ClickHouse, because I work on ClickHouse and TIDB also. So everything is remain same. If you know these basic concepts, you can understand any database which is available in the market. Everyone is talking about these common concepts. Okay, we are going to talk about some more thing which might come into our database architecture, and which is very important, which is related to operating system. Okay, so the first thing that I want everyone to understand about is swap. Anyone understand about swap? What is swap?
Yes.
It's a
Mhm.
it's a storage used for performance purpose. Yeah. The
Okay,
memory.
memory.
So
Yeah.
Anyone?
basically, swap is a block in the disk
Mhm,
wherein when our memory get exhausted or we have a
mhm,
swappiness enabled. So
mhm.
in that case, the data won't go to the memory, it will go to the disk where it
Yes.
is stored in the swap.
Okay, very good. Anyone else?
It is a section of disk that is used as, I mean, overflow memory.
Hmm, hmm. So section of the disk which is sometimes work as a memory. Okay, so how this is interrelated with our database? Why we are talking about here? Why it is important?
So
Big.
basically, when we have basically the DB mostly is performance increases when
Mhm,
we have the data in the memory, right? But
mhm,
our DB size can go further and the memory users also gets
mhm,
used. In
mhm,
that case, the when the memory get exhausted, right?
mhm.
The data comes into the swap disk.
Okay.
So to avoid OMM, like
Mhm,
out of
mhm,
memory issues. So that is why we enable swap in our databases.
mhm. Okay, very good. So uh, let me give a very small example for other people who are not understanding it well, or they might not understanding it. So let's suppose you have a stage. This is the stage, and in this stage, school function is going on. Okay, so stage have its own capacity, right? Let's suppose stage is have capacity of 100 people. 100 people can come to the stage and they can stand. Okay. So what will happen? All these 100 people are there in the stage, but in the stage also we are doing price distribution. Okay. So when we are doing price distribution, what happens? The candidate comes to the stage, he takes his prize and he goes out from the stage, right? In the same way, if the same candidate is getting multiple awards, what he will do? He will come to the stage, he will take his award and he will go, right? But it's not like, right, if he is going to get multiple awards, he will be keep on standing on the stage, right? Practically not possible, right? Because my capacity is only 100 people can stand in the stage, and already 100 people are there, only 1 or 2 people are outside of the stage. So same concept goes to our memory or DRAM basically. Okay, let me not go inside the operating system concept because that will be a little confusing. Let's consider it as a RAM. Okay, so in the RAM, DRAM, when I refer, it is dynamic RAM. So RAM have a limited capacity, and I have multiple blocks standing under the RAM, right? I have multiple blocks standing, mean to say multiple people are standing on the RAM, but everyone is not required in the stage. Everyone is not required. There will be different concept, different applications are running, different utilities are running, and these blocks are nothing but representing different utilities, right? But as a user, who is working on the machine on a server, he is at a time using few blocks only, right? He might be using WhatsApp, he might be using VMware, he might be using Oracle. So only few blocks are really necessary or active or hot blocks. Even in operating system also we have a concept called hot blocks. So let's suppose in this user is using certain applications, so related to that particular applications are only active process, right? But this stage have capacity of 100 people, but these 100 people are already there. So what operating system does, that the people who are not required, they will be parked to the other hard disk or to a storage temporarily, and whenever they will be called, they will be sent back to the stage. So mean to say, temporarily, whatever unused blocks are there in my memory, but my application is still active, we will park into the swap. Okay, and this particular, the temporary part of my storage is considered as a swap memory. Is this clear at least? Why we need swap in the system? The blocks which is not active, but they are still part of the active application, will go to the swap. Why we are talking about here is because our database is going to use a lot of swap or swappiness, and we have to understand this concept going forward when we will talk about the database architecture. Okay. Swap. Anything else? Do you think like which is related to swap, or we are clear about this? Anything else?
Abhishek, can you Abhishek, can you explain giving like example in
Mhm,
database, like in database we observed some like
mhm.
situation where SAP was necessary, something like that. So
Basically,
that will be
when
clear
we
for us.
yes, let's suppose you have a very big query, and that query is keep on running on your database, and the database blocks are, when you run the query internally, it is going through a lot of different structure, right? Let's suppose those blocks are loaded into your instance, and still those blocks are not needed and your connection is idle. So what if your swap is configured into higher level? So what operating system will do, it will send these blocks to your swap space. Okay, and again, whenever you need these blocks back to the main memory, it will come from the swap. The only drawback here is whatever time it takes from your storage to your main memory will be costly, because it will take IO, because your memory is a faster unit and your disk is a slower unit. Okay, we'll talk about that also in a minute. Is this clear? Whatever I have just explained.
Yeah, I heard out. Is this similar to the buffer pool thing, correct?
Correct. It is quite similar to the buffer pool. Uh, when people were designing the operating system, uh, they understood few core concepts. Okay, they understood about some few challenges also. Okay, so the first challenge that we have gone when we were developing the OS operating system, that our memory is 35. I'm just taking a standard comparison. Memory is always 35 faster than the disk. Okay. Memory read is always faster than disk read. That's why if you see all the databases are creating their instances under the memory temporarily. Whenever you start any database, if you start Oracle, Oracle goes and create SGA under the memory. If you take Postgre, it goes and create a shared pool and different pools under the memory, because your disk read is always costly versus memory read. But the biggest problem that operating system faces, that our DRAM, dynamic RAM, is always limited. Let's suppose I have 32 GB of RAM and I'm using multiple applications on my computer. Let's suppose I'm using a lot of processes. Okay, in that case, what happens? My RAM is going to be exhausted. So how operating system is going to handle all these kind of scenarios where my memory is full? They are going and simply doing the aging method in their RAM. So they think, okay, these blocks are still lying on my memory. Do they really require to run the current application? No. So they simply run some kind of algorithms like FIFO, first come, first out, or they run the uh, round robin application, round robin algorithm. Okay, so round robin is nothing but if these particular blocks are not at all used or applications are not using it, simply they will send it to swap to keep them for some time. The moment these blocks are becoming active in the server or operating system, again these blocks will be called back to the main memory. Okay, but the problem here is wherever you are doing any swapping of any blocks, even it is database, utility, application server, your performance might be compromised. So swap and swappiness is another concept that every DBA should understand, because this is related to our infrastructure, or sorry, related to our database architecture. Is this clear, everyone? At least what is swap?
Uh,
Another
uh,
important concept. Yeah, please tell me,
yeah,
David.
swap is it's not from a disk, right? It's a separate entity for a database. I'm right? Or
Correct. It's a separate entity for the database. Just a concept, because we going forward, we are going to combine all these concepts and we will build a database infrastructure. Otherwise, people will get confused. I don't
okay.
want to teach this traditionally, where I just simply jump into a architecture diagram and just start explaining you. In that case, you will never ever understand all these concepts. Okay. Another important concept, two concepts. Let me take forward to this OS to here. Everyone should go and read about these concepts step by step. Swap.
Abhishek, one question.
Mhm.
Swap swap memory is a part of a RAM or it's a part of a disk?
Part of the disk.
Okay.
RAM is just using it as a subordinate, as a co-pilot, just to offload his work basically. But they both are two different entities. Swap is mostly related to disk, but it's also part of your RAM. Okay. Another important thing that we have to understand, which is very important, every disk has its own buffer, which we call as a disk buffer. So basically, when you open any disk, you will find the spindles, and these spindles are nothing but they are actually track where your data is getting stored in like tracks and sectors. To read all these blocks, even disk also have its own memory, which we call as a disk buffer. Okay, so when I refer to disk buffer or storage buffer or anything, I'm referring to this particular part. Even disk also takes a small part of his uh, let's suppose a disk, where it creates its own memory for caching, and it is using it as a memory. It is also related to your database concept. So whenever we go and we buy a NVMe hard disk, let's suppose hard drive, do we check that buffer, right? How much buffer it can store? The more buffer it can store, the more costlier my hard disk will be. So this is another concept which is related to database, but a lot of people don't pay attention to all those things. So here, if I go and see how much, what is the buffer size, it will give me clear cut buffer size that NVMe have this much buffer size. So the more buffer I have, the more my hard disk is going to perform well. Same concept. The more RAM I have in my machine, the more performance I will get. So also we have disk buffer. Okay. So that is another concept that we will refer again and again, and we are going to talk about all those things. Okay. What do you mean by cache? Next concept, cache. What is cache?
Temporary store the data.
Very good. So basically, cache is nothing but a place or a small, I would say the small part which is temporarily used for some process, some utility, some operating system, or anything which is running on your computer. So what it does, it went to my DRAM, dynamic RAM, and it says, boss, your dynamic RAM is 100 square feet. I am temporarily renting out this much space for my purpose. Okay. I will be database, I can be application, I can be Java, I can be Python, I can be anything, but temporarily I am taking this much space. So this is nothing but cache. And this cache will be used for n number of utilizations. Let's suppose if I'm using order by, if I'm using in my query, if I'm doing a left outer join, right outer join, all those things. So temporarily I'm using this space to do some kind of operations. So this is nothing but cache. So if this is cache, then what is buffer? If this is cache, what do you mean by buffer? Because buffer is the concept that we use again and again. So what is cache? What is buffer?
Buffer is a place where the data will be served to the application, whereas cache is nothing but like it is like a friend said, like it is a temporary place where there are some sort of informations are stored temporarily.
Very good. So cache is a fixed part under your RAM, and buffers are nothing but further segregation of caches, which might be exist or might not exist, or they might come and go. They will be there for some time. They will, once their work is done, they will go away from your cache. So cache is a bigger part of your RAM, and buffers are further segregation of your cache. That's why we sometimes we say, right, SGA segment, under the SGA we got this much buffer, all those things, right? That's what, right? So cache is a big memory part. Under that we are just using these buffers to store the data for temporarily. Okay. And that's why sometimes when we define the cache, under that we define the buffer area also. In Oracle, you can say it's like SGA. In Postgre, you can say it's my shared buffer cache. That's what we say, right? So temporarily it is there. It will be fixed that I'm going to use this much space, named space. Let's suppose I will say this is my area and I'm going to use it for a specific purpose. Let's suppose I will say this particular area is only for adding the data, A plus B. This area I will say I'm use only for division. This area I will only for multiplication. So like that, I have decided under the cache, I have decided the buffers for specific purposes. Whatever I am teaching you, these are the OS concepts. If you go to any engineering book or any OS book, you will find the same kind of concept. I'm just giving you some basic concepts so that when we talk about the architecture, we will be very clear about all these things. Okay. What is the third concept that every DBA should understand? What is the third concept? Third concept is IPC. Okay. So what is IPC? Anyone? What is IPC?
It is used to store all this the input. I mean the input agents IP address and their resource. I mean their whatever the applications that are approaching the database, it contains all the information about that. Is that correct?
No, IPC is a operating system concept. It's a little bit different concept. So why I was talking about IPC? Because IPC is nothing but people who are from Oracle, they might understand PMON, SMON, CKPT. So basically, end of the story.
Okay, it is between inter-process communication. Sorry.
Inter-process communication. So basically, IPC is a pipeline between your processes, between your cache to your disk to it can be to the user also, depending. So IPC is not but
process.
Those are separate processes. Let's suppose I want to there is a memory area and this memory area is for a calculator. Okay. So the moment I press 1, my calculator have a input buffer where one block will be stored as a 1. I will say I will hit plus. So which memory buffer it will go? It will go here plus. I will say plus 1. Again, one more buffer will go here. The moment I will say equal to, what will happen? This buffer value will be what it will do? It will add and it will show me the result of 2. But can I see the result here only? No, this is RAM. I can't see the result. So IPC will take this value and it will send it to my display. And in the display, my display is going to display is nothing but a combination of dots, which again refers to 1 KB, 2 KB like that. So my display is going to communicate these two as a result on my calculator. So who is responsible to moving this data? IPC. This guy has completed his work, mean to say this is a small cloud kitchen where food is prepared, but until unless IPC is not available, that food will not serve to the customer. So IPC is another important thing that we should understand, because when you are tuning the databases, when you are tuning the operating system, when you are tuning your web servers, application server, all these small concept is just important. And sometimes in the big companies like Google, LinkedIn, Facebook and all, they want you to understand how you are good with all these concepts. Okay, so that you can do a lot of performance tuning related thing or architecture. Is this meaningful, whatever we are talking about here? Is this good? Are we getting all these concepts? At least basics. I don't want you to become the expert in the first day, but at least understand all these small things so that when we are talking about the architecture, you are good with all these things. Okay. Okay. So this is one concept. Another concept that let's this is going to be the last one, otherwise you people will get confused. Lock. Okay. What is lock? Overall, in general understanding, what is lock?
It's
What
a
is lock?
place where it's a place where uh, to isolate the objects.
Correct. So let's suppose one person is already doing the calculation 1 plus 2 and all. Suddenly another person comes and he started doing multiplication. So it is not going to work, right? Because already one place is already occupied right here for the addition. How he can come and he can do the multiplication. So what are the core concept of the locking? Either we are going to tell him, boss, I have some extra space remaining. You come and you start your activity. Okay. But whenever your process and my process are interrelated by any mean, either we will do sequencing or we will do serialization, or you have to wait for me to finish my job. Okay. So it's like we have a block where already a process is running or process is doing some activity, and same block is needed by, let's suppose this is a process and this is B process. So whenever a process is doing something, let's suppose I am doing some kind of addition 1 plus 2, same time if this person also need this block, either he has to wait or he has to do the serialized approach where he can take some space and he can do his work. But the moment if he need similar kind of information, then he has to wait until unless this guy is done, or we have to find a option where these both people can work, which we again called as a concurrency. Okay, in the database we have a concept of ACID. So there I'm talking about C, concurrency. Okay, so all these things we'll understand, but the lock is nothing but a a, a process where resources are equally distributed or resources are getting used by multiple processes. Okay, so all these core concepts we are going to talk about under the locking. Also, when we will read about lock, we will understand what is shared lock, dedicated lock, deadlock, session level lock, block level lock, all those things we will understand. Is this clear so far? Everything? Just basics. I don't want you to understand it like in the depth, but at least basics are clear before we start the database architecture. Everyone?
Yeah.
If you're not clear, you can raise your hand. We can talk about all these things again, but when we will start our actual database concepts, here and there, all these things will be called again and again. Okay. Anyone? Any question? So I can go ahead, right? No questions, right? Can I get a thumbs up or? Okay, great. So let's start our basic database concepts and some basics of our database like Postgre database. So whenever you are trying to understand a database, you should understand the database in a two different factors. Okay, so two different factors. When I say I'm referring a database or I am dividing a database into two parts, physical part and logical part. Okay, so whenever I am talking about the logical part, I am referring to this particular image. Whenever I am referring to physical part of the database, I am referring to this particular image. I will explain you everything one by one. Otherwise, you will get confused. Okay. So whenever I am talking about the physical part, I am referring to this particular stage of the database. Okay. So logical part. What is the logical part? Logical part is nothing but you have a database cluster. Under that, you have a database, specific database, And under that, you have different databases. Let's suppose A database, B database, and C database. Let's suppose C database have the tables, views, functions, sequences, indexes. Okay, so these are nothing but the logical entity or the logical part of your database. People who are coming from the Oracle side, they can think like this is object and segments. Okay, tables and these objects are nothing but segments. First of all, row. When we combine the row, it becomes segments. When we combine multiple segments, it becomes table. Okay, same concept. People who are coming from Oracle, they think like this, right? Row, segment, object, and or table or something like that. Same concept here. We have multiple objects, and these objects are holding the data, and every object have its own characteristics. Like table is referred as a column and row based database storage unit. When we say index is nothing but indexed unit, which is referring to some other database blocks. Views are nothing but logically, they are not actually holding the data, but they are a data pointers. Okay, functions are nothing but the normal calculation we do, like a simple interest or all those things. Sequences are nothing but when you have to run the sequences from 0 to 1 and then 2 or 3. Let's suppose you are generating a bill or something where you have to create the sequence, and sequence will going to work in the sequential manner, 1 2 3 4 5 6, like that. Okay, so all this is nothing but it's a logical structure of your database. When we are talking about the physical structure of database, so physical structure of the database is nothing but the files which is physically present in your disk. So when I say physical structure of the database, I'm talking about PostgreSQL config. I'm talking about pg underscore hb underscore config. I'm talking about pg underscore indent file, postgre underscore auto dot config I'm talking about, and all the structure which is available after your Postgre database is installed under your directory. Is this clear at least? Physical and logical structure. Physical, simple meaning of physical is I have installed Postgre, and under my Postgre directory, if I can see any file, any configuration file, text file, that comes under physical structure of my database. What this mean? Anyone understand this?
It's an environment variable.
Very good. It is an environment variable. So whenever you install Postgre, by default, it refers to the base directory as a PG data. I will practically show you on the screen also. The people who are coming from the Oracle background, they can refer it as a Oracle home or Oracle base. Okay. People who are coming from the Mongo, they can think like it is OPT MongoDB. People coming from the MySQL, they can think like it is var lib MySQL. Basically a place where I'm keeping my database related files. They are physical location. Okay. So whenever I say logical and physical, your mind should remember these two architectures. Okay. Otherwise you will get confused. Okay. And I'm going to do top ups of all these things step by step. Can we take a break? I want to drink some water. Is it fine so
Yes.
far here? Are we going good?
Yes.
Everyone is happy that we are talking about all those things. Some concepts might be confusing, but gradually I'm going to add everything with your Postgre architecture, and I'll try my level best you can understand all those things. Okay, so let's meet after 15 minutes.
Abhishek, just one question.
Yes, sure. Tell me.
Are we going to talk in detail about connection related processes and
Correct.
architecture stuff?
Everything. Yes, yes, we are going to
Today,
talk about. I will try my level best to finish it, but not today. Then tomorrow we are going to talk about
fine,
the
fine, no problem.
query
Sure, no
processing.
problem.
Yeah, process and architecture also we're going to talk. Okay, so I'm
Abhishek, just one thing, like,
Mhm.
will we be able to like simulate something like, I mean, connections outburst kind of thing, or it will be
Connection
just
outburst. Yes, connection outburst, connection clogging, buffer related thing to the connection. We might cover in detail in the performance tuning. But if
oh,
you want, I will give you a small overview of that also in the class.
uh,
When we are talking about
fine,
the
fine.
work underscore memory and all, right? We'll talk about that
Mhm.
also.
So
But
just
please
want to see
remind,
like,
yeah.
server is getting like completely jammed because of unexpected connections. That is the scenario, like, where we want to understand what's happening on the another side, like,
Sure.
because very limited area we have access to, and if your log settings are not that much elaboratively set up,
Elaboratively.
so you don't get that much of detail.
I
And
got it.
then
I got
the
it.
other world, they are keep complaining about that it's
Yes.
completely DB issue,
Yes.
whereas it is not
Yes.
the case actually. So yeah, I
Mm.
mean, we discussed in the past, but I mean, I just want
Right.
to.
I was yesterday, fortunately, I was talking about same thing. One guy was asking me, why should I use MySQL Community Edition versus Percona? So I was
Mhm.
answering same thing that if you're using the community editions, you might not get the fine-tuned information about all those things like your SQL buffer area and all, right? Same way in the Postgre. But when you have Percona MySQL or Percona Postgre, you get a lot of other utilities which can give you a very specific information. No problem.
Mhm.
We'll talk about that in detail.
Yeah, sure, Abhishek.
But don't hold
Okay.
your question. If you think that something is coming in the mind, just ask that time. We
Sure.
can have a discussion. Yeah. Okay, guys, I'm stopping the recording. Please remind me. And in case if you have any question, just note them down. We can have a discussion after the break. Fine, everyone?
Yeah.
Okay.